This is Jennifer. Maybe this is also for Carla as well. Still closer? Okay. Approximately what depth are we looking at with Rob's testing? Do we know approximately how deep that might be?
Rob's what?
The testing that they're going to be doing in November?
With your experience with his analysis down in Chile, do you recall he should get over 30 meters? It really depends on the frequencies he's using and the spacing of his sensors. But yeah.
Well, I have to take a look at it.
At least 30.
Sorry.
Even if he gets deeper, the uncertainties get larger with them. So I mean, you can hope for 100 meters, but when he goes deep, the uncertainties are large. Since I have the microphone, can I point one thing, Norm? You talked, this Adrian, you talked about instrumentation at nuclear power plants to get information for the future. We should have instrumentation that goes to high frequencies so that we can also use it for Kappa. I think that's self-evident.
Yes, I fully agree. You're in a difference between the seismology world, where they have one goal, and the ground motion world, where we're trying to do something else. So we've been unsuccessful so far in really getting the national arrays to get up to the frequencies we need for Kappa.
Yeah, I guess we'll have to wait for TIRA 2. Yeah, well, my question was, and I guess that's to the project, and maybe related to the fact that I was during earlier workshops. Which Kappa is this project estimating? Kappa bedrock, say, on the basalt for Palo Verde at 760 or where?
Good question.
We are looking for a Kappa knot, so that at below the Kappa that goes with the input rock level,
Okay.
so that below that we're going to assume no damping if anything is done below it. So
Okay.
it's going to get everything up to that point. Above that, the damping would be captured in the geotechnical model.
Okay.
So these Kappas are surface Kappas, and we need to be able to get rid of the effects of the soil.
So again, then Jennifer's question becomes very relevant because you need to determine the thickness of that sediment cover.
And I think we talked about those depths before, and I thought they weren't especially deep.
Palo Verde is a couple hundred feet deep.
Correct. So a couple hundred, so talking meters,
Okay.
right?
Well, okay.
So say 60 meters. All right.
60 to 80 meters deep, something in that order. Depends on the units and so on.
Right. So that part is what will be characterized. The
Okay.
issue is on these sites, what can we do? And with the data from Rob, it will be much better than trying to take these general maps of soil data.
Okay.
So back to doing a better job, right?
Okay.
Not making things worse. I think this is clearly an improvement, but the answer to the question, we're after Kappa that goes where we are no longer at the level below which we're modeling the geotechnical properties.
Yeah, but I guess also the message to Rob Kyan is don't stop at 30 meters.
If you can go
deeper, go as deep as you can if you can. And I would say, not being an expert on SASW, my feeling is his interpretation of what lies below is better than any of ours.
I would agree.
So to try to push the data collection as far as possible, and then the interpretation as far down as possible.
Can I answer something?
Just a second on that. I want to add that on the scope of work, he's going to provide the VS at the maximum depth that he can reach, so that the information is going to be provided. Olga, did you want to answer to any of the questions?
Yeah,
okay.
partly.
Go ahead.
Unless I've spoken too much, then I'm going to be shocked if I speak anymore. So I think it's kind of a hard question. Like, well, it's an easy question to say, where do you want your Kappa, and then I have to find it for you. But I think it's hard to kind of make the distinction when we're talking about Kappa and amplification, because, for example, what I tried to pinpoint with the H/V, which I know is no panacea, but it's something I think can kind of illustrate a few issues, is that one thing is having different, well, we're talking about surface Kappa to begin with. So you can have like a high surface Kappa because you have alluvia with a low VS and whatever, or you might also have a low underlying Q because you're in a messed up zone whose underlying rock is not very healthy. And that'll give you like a low kappa 0 value. And right next door you can have a site on rock, and let's say this rock has kind of a beautiful near unity, almost flat transfer function to it. So no really weird high frequency side effects. And that should have a lower kappa 0. And those are both surface kappas, and if you want surface kappas, that's grand. What I was trying to show is that if you have some sort of kink in the transfer function and you don't have enough bandwidth, you kind of surf down it, and that's what Paralai and Bindi talk about. So that is a wrong kappa for me. That is the, just allowing one resonant peak guide you, and that is totally wrong. So if you could have like data out to 60 hertz, I mean, that sounds funny because 16 hertz is apparently very broadband, but anyway, if you can like cut through them, then you would have like a slope still that's not guided by the individual peaks, and it would be a shallower slope than for the nearby site, which would have a steep slope because the kappa would be high. Then if you want to take out the amplification and go down, the question is which amplification. So I've tried to deconvolve with like a 1D transfer function that accounted for maybe 100 or a couple of hundred of meters on some data set I worked with, and I got some results, but that's very different to saying that I want to go down to like, I don't know, the seismic depth or like 8 kilometers or whatever, which would be like comparable to the, where you apply kappa like for the simulation models. So I think it's kind of different things we're talking about sometimes when we're considering amplification. I just wanted to kind of put that in there.
If you go deeper, you're only gaining the low frequency of the amplification, which shouldn't matter for your kappa because the shallower stuff controls the high frequency, right? So
Well,
it
a
would
few people will say that kappa 0 is dependent on like a stack that might
Yeah,
go
kappa
down to
zero,
like 6
one of-
kilometers or something. Like the Ken is one of them, so don't say no.
since Walt is not here, I'm gonna say I read it in a Silva report,
Yeah.
1 or 2 kilometers.
Apparently, the geotechnically speaking, damping might control the kappa, but it's just a matter of what do we mean by kappa and where do we want it.
Yeah, no, I agree, but I mean like for the side amplification, just going deeper is not gonna matter at the higher frequency. That's what I'm trying to say.
But you would still want to know the depth of the soil so that you can
Yeah,
get the
to
total
get-
damping in.
yeah.
So it's not the profile as much as the depth, right?
Yeah, the layers.
Right.
Yeah, I mean, yeah, like 1 kilometer will not give you like any interesting peaks, but it'll be working on the Q afterwards.
All right.
Can I show 2 slides? If
Yes.
you're done.
Uh-huh.
You're done?
Yeah.
We'll
Thank you.
Don't eat.